So 1 over x, here we have our graph. Let's graph it. This is our x-axis. We're working on the right-hand side of x equals to 1. So we're going to ignore left-hand side of the graph. X-axis, and here you have your y-axis. This is your function, the graph of the function. It behaves like this. Okay. Continues. And we want to know what's the area on the right-hand side of x equals to 1. So this is 1. This is the area that we want to calculate. What is this area? Okay. So we are calculating the integral, improper integral, 1 to infinity of function 1 over x dx. Well, let's apply the methods that we learned. First of all, since one of these boundaries goes to infinity, we're going to use limit concept. So this is equal to the limit of the integral 1 to L as L or T. Sometimes you can just change these variables. This is just a variable. L goes to infinity, so it's not important to use one variable. L, T, different variables. 1 over x dx. We already know how to calculate this definite integral. Here you have your limit. Let us copy down the limit as L goes to infinity. This is the integral of ln. So we have ln of absolute value of x, and x ranges between 1 to L. Very well, okay. So I have the limit of as L goes to infinity of ln of M minus ln of 1, which is 0. So ln of absolute value of L. And note that ln of 1 is equal to 0. So I'm not going to write this down. The limit of ln of infinity, this is equal to infinity. So this area, the area gets larger and larger. It's not a fixed number like previous example, which was 1. So this area is infinity. For this integral, the area below this function is infinity. So as you can see, you're dealing with two types of areas calculations when it comes to improper integrals. Sometimes it converges to a nice number, like previous example, 1. Some other times it diverges to infinity. So when it comes to improper integrals, we're dealing with two types of integrals. If the limit exists, we say that we have a convergent integral. If the limit doesn't exist, or it's going to infinity, we're dealing with divergent integrals. So for improper